And welcome everybody to the Daily Space Weather. We've got this awesome trans-equatorial plasma event happening here. Right there on the eastern limb, right over here. Some sunspots interacting. Some plasma splashing back down where the coronal mass ejections. We'll also show you the latest... Whoops, I'm back. We'll show you the latest cosmic ray report as well today. Lots more fascinating information, as always, on the Daily Space Weather. The recurring feature of the Smash News Network least busted name in news. So this is some composite imagery here. This is 3 different species of ionized iron, 335, 193, and 94 angstroms from SDO. Spectacular event there. And more sunspots. Lots of sunspots. So let's go around the horn. We do have a filament fest continuing, especially in the southern hemisphere. Huge plasma filaments there. We've been naming them on Twitter. So make sure you follow us over there on Twitter at Smashomash. There is your northeastern hemisphere. Here is your northwestern hemisphere. What the heck? There we go. The Ye filament and Rene Gable filament, both visible in this imagery. Here is the southwest. And let's take a brief look at sunspots and magnetic fields before we move on. What is happening here? Okay, let's try this again. Ah, the dangers of live streaming, yes. Let's bring up the orange intensity gram for once. So that is imagery from yesterday plus today. And I'll just say that's lots of sunspots. We'll have the sunspot number increasing today, possibly another increase in the radio flux as well. So lots of solar activity to cover. Let's briefly take a look at Crescent Earth here for a moment and see what's erupting in terms of volcanoes. So Sakurajima is erupting. It's producing a 7,000-foot ash plume, flight level 070. Luatolo in the Lesser Sunda Islands. Explosive activity happening there as well as a seismic signal. The warning bulletin states that ballistic impacts of volcanic bombs and pyroclastic flows could affect an area of about 2 kilometers distance from the main crater. Please do not pole vault the caldera. Krakatau erupting, producing a 2,000-foot plume of volcanic ash. Semeru, 15,000-foot plume of volcanic ash over East Java from Semeru. Merapi, flight level 110 from Merapi. Kerinci exploding, flight level 150 over Sumatra. 15,000-foot ash plume from Kerinci. 19,000-foot ash plume from Popocatépetl over central Mexico. Fuego in Guatemala. Also exploding, flight level 150 from Fuego. 21,000-foot ash plume as Sangay explodes in Ecuador, also Revenador in the same nation. 15,000-foot ash plume from Revenador. 23,000-foot ash plume from Cotopaxi in the same nation. So 3 significant volcanic eruptions occurring in the same country, the small nation of Ecuador. Flight level 230 from Cotopaxi, flight level 220 in Peru over Sabancaya. Looking at earthquakes, and it's been pretty seismically calm here for the past 24 hours. Not a large number of quakes and no large quakes. So here's your 24-hour list. We're only going to cite quakes over a 5 magnitude range, 5 or larger. And I think there's only one quake to report on. It's this 5.3 at Indonesia. So that's the largest quake of the past 24 hours. Again, seismically calm conditions, folks. Not a lot of quakes, and certainly no large quakes. Let's move on as the action is happening back in space. Here we've got ionized helium plus ionized iron. That's 304 plus 171 angstroms. And I would note once again this plasma reorientation happening here. You can see this brightening as a bunch of coronal plasma splashes back down onto the chromosphere. Fantastic imagery there. Let's check out just 304 angstroms by itself, just ionized helium. And you can see a lot of ionized helium showing up there as that plasma splashes back down onto the solar surface. Yes, the surface. Is it a real surface or an imaginary surface? Is it an illusion or is it really with a surface? Let us know in the comments what you think. The 10.7 centimeter radial flux has dropped down 3 points to 209 solar flux units. And there it is, having just reached the new high of solar cycle 25 yesterday, coming down from 212, now down to 209. Once again, I think it may increase today. We've got a lot of sunspots in the eastern limb, which may not be having their full effect on the radial flux yet. Taking a look at the space weather enthusiast dashboard here, this is NOAA's forecast for geomagnetic storms and geomagnetic unrest conditions, and we ain't got none. Things are forecasted to be geomagnetically calm. We did recently see a big, significant uptick here in the solar wind speed. Looks like a coronal hole high-speed stream. We'll get to it here in a minute. First, let's do a cosmic ray report. We try to cover it at least once a week on the channel. So let's see what's happening in terms of deep space particles, making it all the way down to ground level. So here is our DOMB Antarctica monitor, and you can see a significant downtick in cosmic ray flux there over the past 30 days. DOMC Antarctica, a similar graph there, somewhat of a downtick for the past 30 days. Let's go way up north to the land of Finland. There's Oulu showing almost the exact same graph on the opposite side of the planet. Downtick at Oulu. So let's go way down south to the land of Mexico. There is the Mexico City Cosmic Ray Observatory. Similar graph there. Also a downtick in the past 30 days at the Mexico City Cosmic Ray Observatory. And let's don't forget Athens, Greece, one of the monitors we show regularly on the channel. Also a downward trend over the past 30 days at Athens. Last but not least, let's take a look at Apatity and Barentsburg. Going way back up north once again, there is Apatity. Apatity, a similar graph there, a downtick over the past 30 days. And Barentsburg, a similar graph. So that's great when we see those data sets all aligning that way, an indication that they are probably legit. Cosmic rays have decreased for the past 30 days. Let's get back to earthly geomagnetism here. KP is currently at 1.33. So KP 1.33 is the geomagnetically calm condition. If we see a shift in the field, we could see a sudden geomagnetic unrest situation here, as we do have an elevated solar wind speed. We'll get to that here momentarily. First, the last 4 hours of Earth's magnetic moment from space. So that's what's likely going on out to about 12 Earth diameters. Some variations in the solar wind happening there. Let's take a look at Earth's magnetic moment from the ground. That is the last 4 hours of changes to Earth's B field, known as geospace delta B. The B field being the field that goes through the magnet, this magnet being the Earth. Again, geomagnetically calm conditions here. You might see a little uptick there right at the end. Besides that, pretty chill. Now, like I said, if we see a shift in the magnetic field, if we see this BZ go into negative territory, that could create geomagnetic unrest or storm conditions. But at the moment, things quite calm here. So solar wind density, about 8.4 protons per cubic centimeter. Solar wind speed, over 500 kilometers per second there. Looks like a sort of a weak coronal hole high-speed stream at the moment here, because we saw a weak uptick in the solar wind density right here. It got up to about 15.3. And then as that came down, the speed came up. But it doesn't look like a very definitive solar wind, a very definitive coronal hole high-speed stream, rather. Again, it's looking kind of weak. Continuing on to our magnetic data, there are the GOES magnetometers. And we are seeing some sawtooth readings there showing up in the GOES 16 and GOES 18. Those are consistent with coronal hole high-speed streams. And let's take a look at the heliospheric current sheet and its polarity. Next, Earth is now in a North Pole current sheet. Welcome to the North Pole current sheet. It's depicted here in green as the South Pole current sheet rotates off to the west. Stereo B is now in a North Pole current sheet as well, depicted with this little plus sign. That's stereo B at Lagrange 4, and there is stereo A at Lagrange 5. Let's take a look at the solar magnetogram plus line of sight field plot. Here the sun's B field is depicted in blue, solar polar fields in green for north and red for south. Let's move to coronal holes next, as we've got some North Pole oriented ones here rotating in from the east. There is a trans-equatorial coronal hole. Those are the most geo-effective ones. Trans-equatorial coronal holes are the ones most likely to produce significant geomagnetic effects on planet Earth. Let's take a look at those from the perspective of SDO as opposed to these ground-based observatory data. There is SDO, our space-based ultraviolet imagery in 211 angstroms. So this coronal hole over here is pretty significant. It is crossing the solar equator. It is North Pole oriented. We can expect a high-speed coronal hole wind stream from that in about 5 days. Let's move to sunspots next. And we have got a lot. I'm not going to try to name them. But yeah, we've got multiple groups here. So we can expect to see the sunspot number rise to a new high once again here, as we've got several different new named sunspot groups. We've got more sunspots rising and forming than we do setting. So expect the sunspot number to rise, along with the radio flux in the coming 24 to 36 hours. Let's take a look at sunspots from SDO, the Solar Dynamics Observatory. So there's 171 angstroms plus the SDO continuum imagery. And let's subtract 171 angstroms. And zoom in here. Not a lot of evolution happening with these sunspots in the past 24, which is the amount of time these HelioViewer movies depict. So this group up here is quite complex and quite irregular in its shape, the orientation of the way the umbrae are lined up versus each other, and so on. You can see various different latitudes there. So expect the sunspot number to rise and the radio flux number to rise. Again, more sunspots are rising and forming than are setting in the west. Here's your SDO magnetogram one more time before we move to things like flares and energetic particles. So we did have a little proton spike yesterday. It was very minor. It probably only barely caused the most minor of polar radio blackouts by modulating the D layer of the ionosphere. In any case, here's our flare profile. We did have this long duration flare that was associated with that plasma reorientation. The trans-equatorial plasma reorientation we started the video out with. Oftentimes, long duration flares like that feature all kinds of spectacular events occurring. So let's take a look at this from the perspective of SDO once again. There is 94 angstroms. And we're going to take a close-up look of that activity. Here it comes. It's the money shot, as we see sunspots interacting with each other there across the solar equator. Not something you'll see every day. We'll let it play through a second time. Here's the exact same area and time period in 131 angstroms. And there is your full disk view. Likelihood of large solar flares, higher than 50%. Don't be surprised to see M or X class flares in the coming day or two. we definitely have the right scenario for magnetically complex sunspot groups. So let's take a look at what's going on over our heads in Lehigh Valley, Pennsylvania. We've got Mercury and the Sun having recently risen here, coming at you a little later than normal today. Congratulations on realizing the channel exists and stargazing with us. That's in-the-sky.org, by the way. And let's do a solar system forecast. If you're wondering what this one is, keep in mind it is not to scale. This is theplanetstoday.com. And here is your solar system forecast. There's where things will be in a week as we approach a new moon. And Earth moves to the lonely side of the Sun, the side devoid of gas giants. Next, we'll look at coronagraphs. Are there any coronal mass ejections headed toward Earth? Well, in short, no. That's yesterday's imagery. Here is today's imagery. Some minor CME activity there. Nothing to write home about. Let's take a look at stereo A, which is the great thing about stereo A, folks, is that when you look at stereo A's perspective, stereo A is looking in this direction. And it gives us some indication if a CME is headed toward Earth. What we really need is a new stereo B out here at Lagrange 4. That'll give us really definitive information about whether a coronal mass ejection is headed toward Earth. We want a stereo BX because we want an X-ray detector out there because of the possibility that solar flares are anisotropic. Anyway, here are the coronagraphs. Stereo A on the left at Lagrange 5. Soho-Lascaux C3 on the right at Lagrange 1. And it is pretty clear in between Earth and Sun, except for that coronal hole high-speed stream that's showing up. And I don't think that's very perfectly directed toward Earth. I think it's a bit off to the north, so I don't think it's going to last very long. I think the solar wind speed is going to subside here in the next 12 hours. In any case, there is what's going on for the past 24. We'll zoom out a little bit to continue to show the most detailed imagery of the Sun that you'll find in the known universe. How about one more layer of zoom out? There is a relativistic particle strike when you see all these little blocks appear on the screen. That is an indication that the Soho-Lascaux C3 got struck with some relativistic particles there. Keep in mind the spacecraft at Lagrangian point 1, they don't really have any sort of a magnetosphere, so they are in empty space, unlike Earth, which is protected by a magnetic shield. Continuing on to look at filaments. And again, let me just say this again. The filament fest continues. The likelihood of coronal mass ejections is very high. We've got more filaments than I can remember the names of. Up here we've got the Rene Gable. We've got the Ye down here. Then we've got the Bill Nye setting down here. We've got the Zach Tovin. And then here you've got, I guess that's Liver King. This one here, I don't remember what it's called. So this one needs a name, though. So join us on Twitter. Why? Because you're all invited to name that filament. Again, I mean this one. It's very dense, very well defined, and it needs a name. We're naming filaments after living people. They don't have to, they could be a brain dead living person, but you get the idea. Anyway, join us on Twitter to name that filament. And let's take a look at some more imagery here. Here's the last 24 from SDO 193 plus 304 angstroms. It's where we started. We're almost to our bonus features segment here. First, the last approximately 2.5 hours from GOES 16 SUVI. And there's a CME happening right now, right down here in the southeastern limb. Some of that ejecta most likely is exiting as we stream the video. By the way, this video was originally streamed live to twitch.tv/smashamash. If you don't catch the videos live, you won't see them. They get unpublished, and then they become exclusives on BitChute and YouTube. By the way, if you're viewing on BitChute, make sure you go subscribe on YouTube. You're missing most of our content. And here come the bonus feature segments. Starting out with satellite charging hazards. We ain't got none. It's clear sailing for satellites at the moment. Expect good data coming back from your favorite satellites. Goes electron flux here. Came off the floor a little bit. We can expect to see this remain kind of low, at least during the current coronal hole high-speed stream that we're seeing. There's the forecast model, and I would tend to agree with that, as it is consistent with what I just stated. The green boxes of the forecast. Here's the one-year chart to put the relativistic electron flux into context. We'll also show the F flare of the ionosphere, since it's where that is measured. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation, thermospheric temperatures, and molecular densities. Here's the F flare of the ionosphere. It's located at about 300 kilometers of altitude. This is the vibrational frequency, the raw data courtesy of Australian Government Bureau of Meteorology. And we are seeing continued anomalies occurring in the ionosphere. So we've started covering it weeks ago. It was not something expected to see, but that's what happens in science, man. In the realm of science, what happens is you ask questions, and oftentimes you end up with no answers to the questions asked, additional questions, and answers to questions not asked. So that's a thing that's been going on with the channel. We weren't expecting to explain the solar sunspot cycles and the mechanism underlying them. We just have. So that's just the way it works. You got to follow the facts. In the realm of science, here is your anomalygram for the F flare of the ionosphere. Lots of high-frequency anomalies here around the equator and in the northern hemisphere. That is anomaly in megahertz from a 30-day median. So we've thoroughly documented the fact that the South Atlantic anomaly is now in the South Pacific, right about where my pointer is. It's really obvious from the anomalygram. You can see it's right there. Also, the South African anomaly has moved up here into equatorial Africa. Quite interesting indeed. And perhaps the ionosphere there giving us insight into the internal structures that are responsible for Earth's magnetic field generation. Let us know in the comments if you have a theory as to how Earth's magnetic field is generated. I think the sort of mainstream science accepted version of how it's generated might be a little bit on the incorrect side. Anyway, there's our latest image. That's 1330 universal time ionogram, and there's 1330 universal time anomalygram. Perfect example here of a wild swing there. Low and high frequency anomalies very close by to each other, a huge rift. That is a low and high pressure zone, if you will, in the ionosphere, right over Central Africa. Continuing on to our total electron content forecast. It shows the free electrons between your GPS satellite and your handset. Those free electrons can cause signal refraction, aka GPS errors. Your GPS could be off by thousands of miles in large portions of the globe here, as we've got lots of free electrons out of place. This has been going on for a solid week plus. Huge GPS errors happening here. Lots of free electrons sort of out of place, as they tend to be concentrated around the equator at noontime. At the moment, all over the place. Massive GPS errors expected over North America throughout the daytime hours. And only a small respite there. We'll let that play all the way through. Lots of free electrons there in unexpected locations, perhaps. Turn on your Wi-Fi accuracy if your GPS is off by thousands of miles. It could make it off by a matter of inches. Anyway, here's your latest magnetogram and latest intensitygram. This sunspot group here, I think it's actually two groups. That is quite magnetically complex. The likelihood of that producing X flares is very high. It is certainly beta gamma delta class. This group down here, that is definitely beta gamma class. This group up here looks like it's weakening a little bit, so that's not quite as magnetically complex. It is still beta gamma delta, though. And don't be surprised to see a large flare from this setting group in the southwest. Here's your rock back, and that is, once again, a lot of sunspots. And thanks to each of you for viewing in to our insight into space weather. If you want to support the channel, consider becoming a member of the Smash Team. Smashomash.com/Smash Team was launched to replace Patreon, but we still do have Patreon. So back in October of 2021, we did indeed launch Smashomash.com/Smash Team. It's got superior capabilities to Patreon, so that's the main thing. We are still on Patreon as well. So if you want to support the channel by sending us a few bucks per month, consider a gold or silver Smash Team membership. The best value is the gold annual paid-up subscription. It's like getting 4 months of the gold membership for free, as it includes complimentary merch. Smashomash.com/Smash Team. It's where you can support the channel. We are also still on Patreon if you find it more convenient to increase the probability that we'll continue to create these videos and for them to remain publicly visible and free for all to see. Support us via Patreon, as we make just this side of nothing to put the content on YouTube. You can also help us out with merch, give Smash staff a raise, perhaps with some merch. If you click the link below the video or on the homepage at smashomash.com, you'll find our merch in order of best selling. So keep in mind, I am apolitical, so if you think you have some sort of a political rift with me, you probably do, because if you belong to any political party, you're going to have a political rift, as I don't belong to a political party and probably never will. My views are way too nuanced. So check out the products, all kinds of different products there with different purposes. Today's featured product is, and congratulations on surviving a global pandemic so far, is the Smasher Price, My First Pandemic. So, of course, most people on planet Earth have only been through one pandemic, because if you weren't around during the Spanish flu of 1918 and so on, you may have never experienced one. So congratulations on surviving one so far. As large portions of the planet continue to mask, whether or not that is effective. Let us know in the comments what you think. How's masking the planet been working out? Just asking questions, folks. Just asking questions. Wouldn't want to get some kind of community guideline strike just for stating facts on YouTube. That would be very unfortunate. So check out some merch. This is a re-release, actually. It was one of the first pieces of merch that we ever put out. You can find links below the video and on the homepage. Thanks to our YouTube subscribers for tolerating the pathetic and putrid censorship on the platform. We're glad that you are able to survive all of the nonsense, propaganda, fraud, and misrepresentation of science facts on YouTube. We try to avoid that. If you haven't checked out our playlists, check them out. There are all kinds of videos about things besides space weather and meteorology, like what about the 12 Days of Smashmas? Yeah, we have a record label. It's called Golden Cat Productions. Also, check out smashomash.org presents The Sun, the cosmology segments, the Diamond Anvil, Too Hard to Smash, Terms Defined, Driving, Riding, and Pro Tips, and lots more. Once again, thanks to all of our YouTube viewers. Thanks to our friends and to our foes. Smashomash.com is the homepage, so visit us on the internet. Changes coming to smashomash.com here as the scene blows up. Smashomash.com. Welcome to the Neo Renaissance. Congratulations once again on realizing the channel exists. Help us out with clicks. And visit us on social media. Let us know what your favorite social media is on the comments. We'll be happy to join you over there, perhaps. Next thing we're looking at here is meteorology. So welcome to the meteorology segment. Just showing you one of the features here of nullschool.net. So one of the many layers that you can add here is we've got surface winds here, and we've got the 3-hour precipitation accumulation. So I figured I'd just take a brief look at that to see what's going on in Northern California. It's not that bad at the moment. The last 3 hours have only featured 0.7 of an inch. Okay, that's pretty much rain. And they certainly don't need it. So yeah, those are the surface winds and the most recent precipitation. 3-hour precipitation totals. Here are the surface winds of the eastern world. Shout out to our viewers from the most populous portion of the planet. Right in here, you've got over 2 billion people just in that circle. Here are the jet streams of the east. jet streams of the west. You got some cold air dipping way down to places like South Carolina in the U.S. There are the surface winds of the western world. Strong low here northwest of the Azores. Here are the surface winds of the central world and the jet streams depicted thusly. Moving on to see what's going on in terms of clouds and fog over the Americas. Some rapid cloud nucleation happening there around the Andes. That is 3.9 nanometer radiation from the NASA GOES Interactive Weather Satellite Suite. And let's take a look at some maps. Here is our weather.gov map. If your location is lit, click your county or your waterway, wherever you're located. Click your location. If it is colored, there is the key to maybe prevent you from going to weather.gov. It's a pretty well done website, though. I mean, it's okay. Not all government websites are acceptable, but this one's fine. Lots of weather warnings there, especially west of the Rockies. Let's take a look at some forecasts. Here is our pressure and precipitation based on the GFS model for the next 72 hours. As massive amounts of precipitation continue to inundate California with snow and rain. Here is our total accumulated precipitation in inches for that same model, the GFS 72-hour forecast. And some of that precipitation will be falling as snow as well. So let's take a look at the positive accumulated snow depth change in inches, and expecting over 3 feet of snow there for large portions of California. So most of the snow there is going to be on the western portion of the Rockies. Let's move on to show some more in-depth information here. Another feature of windy.com. So here's another great feature here that you may not be aware of. This is the drought intensity. So super interesting here. All kinds of different features on windy.com. They've got a mobile app that you can install. It's just splentacular. Drought intensity. One of the features you'll see. There you go. There are some of the worst droughts. Central Africa, the northern African desert regions, and so on. So the drought situation, not as bad in the U.S. as it is in many locations. Droughts largely have been averted here in the past few months. And let's take a look at lightning. Some strong lightning in the West Atlantic there. That's the last, 10 hours. And how about a real-time lightning map? Do we have terrestrial strikes? Not so much. Not in the U.S. There's your full globe view there from lightningmaps.org. Check it out next time you hear thunder. It's good stuff. If you want to know where the teeth of the storm are located, lightningmaps.org. Here's your U.S. Doppler radar map. The full 50 states of ALSA, former nation, now Banana Republic. And we'll focus on the lower 48. Please do not cross floodwaters. It is some bad stuff going on in California. Check out the low clouds over the Atlantic seaboard and the Gulf of Mexico. Lots of low clouds there. That's our 3.9 nanometer radiation map showing clouds and fog, and here is water vapor. And you can see that cold air being infused down into Tennessee and so on, moving its way toward North Carolina. You've got some cold air coming your way. The water vapor map is great to clarify things if your Doppler radar is not giving you the full picture. Here's a recap. It's time to close this mother out. U.S. Doppler radar. Clouds and fog. And we'll close it out with water vapor. So thanks for tuning in, viewers. Congratulations on realizing that the Smash News Network least busted name in news exists, despite the pathetic and putrid censorship by big tech organizations who have essentially outlawed facts on the internet. So it's kind of unfortunate. However, these organizations are self-destructing. They can't break the internet, but they can destroy themselves, and they're doing a fine job of that. See their stock share prices for additional details about their self-destruction. Anyway, thanks for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech criminal organizations to increase the quality of your online experience. Opinions stated in this video not necessarily the opinions of Smash News Network, least busted name in news.